This problem can be found on page 360, number 39 in the Chapter 6 review. So what we have here is x to the 6th plus 16x to the 3rd plus 64 is equal to 0. This can be recognized as a quadratic pattern. So what we know is that if we simplify it will simplify as x to the 3rd here and x to the 3rd here, because x to the 3rd times x to the 3rd does equal x to the 6th. And then also we need to find a number that multiplies to be 64 and adds up to be 16, and we know that is 8. So we fill that in as x to the 3rd plus 8 and x to the 3rd plus 8. So now what we have here is a sum of two cubes, and we know that a in the scenario is x and b is 2. So what we do here is we use the formula for the sum of two cubes, which is a plus b times a squared minus ab plus b squared. So then for here, we fill in a and b. We know that a is x and b is 2. Next, what we do is we have to fill in the a's and b's for this side. And then we know that since a is x, we have to do x squared. And then we have to do negative a times b. And a times b is 2x plus b squared. B squared is 2 times 2, which is 4. So what we have to do next is find the zeros, because the equation, as seen before, is x to the 6th plus 16x to the 3rd plus 64 is equal to 0. So we need to find the zeros of the function. So first we have to set x plus 2 equal to 0. And what we do is we subtract 2 from both sides, and we get x is equal to negative 2. So this is one of our solutions, and now we have to find the other. So this can be factored even more than it is right now. So what we would have to do is first look to see if there are any numbers that multiply to 4 but add up to negative 2, and there are none. So what we have to do is use the formula, which is negative b plus or minus the square root of b squared minus 4 times a times c. So then if we fill in, so then we need to figure out what is b and what is a. Oh, excuse me. And then this whole formula is over 2a. So then we know that this is a, this is b, and this is c. A, b, c. We can write it on the side as well to clear it up. So a is equal to 1, b is equal to negative 2, and c is equal to 4. So if we plug in a, b, and c into the equation, it will be negative b, which is 2. So it'll cancel, making it positive 2, plus or minus the square root of negative 2 squared minus 4 times a, which is 1, times c, which is 4, all over 2a. And a, in this case, is 1. So I'm going to jump up here now. So if we simplify this, we have positive 2 plus or minus the square root of, here, you can see it here, the square root of negative 2 squared is equal to positive 4 minus 4 times 1 times 4, which equals negative 16 all over 2 times 1, which is 2. And so then when we go back up here, we now have a more simplified version of this. So then next we have to take negative 4 minus 16. And so we have 2 plus or minus the square root of negative 12 all over 2. Now, the square root of a negative number produces an I. So what we do is we do 2 plus or minus blank I root blank. And so then now we still have to find out what the square root of 12 is. And the square root of 12 is 2 root 3, usually. It's like the square root of 12 is equal to 2 root 3. And a way you could check this is by taking 2, and if you put it under the sign, this sign here, then you would, and if you multiply it by itself, then multiply it by the number that is there, like 3. So an example would be, what we would do is if we put 2 under, then it would be 2 times 2 is 4, times the number that's there, which is 3, equals 12. So it's the square root of 12, which is right here. So, and then we had the I because it's a negative number. So it's 2 plus or minus 2I square root of 3 all over 2. But this still can be simplified more because of the coefficients here. They are multiples of 2. So then if we divide, 2 divided by 2 would be 1. 1 plus or minus 2 divided by 2 would also be 1, but we don't need to write it there. And then these would cancel, these would cancel. So then it would end up being I plus or minus, or 1 plus or minus I root 3. And this would be the other solution. So then your two solutions in the end would be x is equal to negative 2 and x is equal to 1 plus or minus I root 3. And what you would know is that this is a negative 2 with a multiplicity of 2, and this is a 1 plus or minus I root 3 to the multiplicity of 2, because we only solved for one part. So we know, since x to the third plus 8 is the same on both sides, we know that it's whatever we did, the work that we did for the left side will be the same for the other x to the third plus 8. So then we know that this is a multiplicity of negative 2 and 1 plus or minus I root 3.